Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about Biot Savart law for NEET and JEE exam. From the hosted principle, we got that current carrying conductor produces magnetic field. But we didn't get an idea about the magnitude. That magnitude we will get from the Biot Savart law. Okay, so I am considering current carrying conductor. This is a current carrying conductor and a small element dl. Through this current is to be I. Okay, I amount of current is to be passes through this direction, and there is a point P which is r distance from the current carrying conductor. Okay, so Biot Savart law said that magnetic field produced by a small current element at a distance, at a point which is r distance from the current element, dB is equal to mu 0 divided by 4 pi I dl sin theta divided by r square. I is the current flows through the current element and dl is the length of the current element. Theta is the angle between r vector and dl. Okay, this is the theta. And r is the distance from the current element. Clear? Okay. Then, in the vector form, we can write that mu 0 divided by 4 pi I dl cross r cap divided by r square. From this, you can say that the dB is perpendicular to the plane containing dl and r cap. What is r cap? R cap is a unit vector along the direction of r. This is to be the r cap. Okay, clear? So from this we can find out the direction, that is by using right hand rule. How you will apply the right hand rule? You place your right hand in the direction of first vector and curl towards the next vector. That means I place my right hand in the direction of dl and curl towards the r direction. Then I will get the magnetic field is going into it. That means here the magnetic field is like this. Okay, this is the magnetic field direction. Clear? What is r cap? R cap is equal to r vector divided by modulus of r vector. Okay, this I will substitute here. Then I will get dB is equal to, that is dB is equal to mu 0 divided by 4 pi I dl cross r vector divided by r cube. Clear? So this modulus of r will be come to the denominator. Okay, this is also another expression. Okay, clear? Next we will see some cases. Case 1, theta is equal to 0. When theta is 0, theta equal to 0 when r and dl make an angle 0 degree. That means the point P is along the axis of the current carrying conductor. That means this point is shifted to here. That means we can draw like this. This is a current carrying conductor. dl is like this. This is the small portion dl and the current is to be I here. So if a point is to be here, P is a point. So what is the P? P is to be here. So R vector is from this to this. So you can see that dl have the same direction of I. So the dl and R are same direction. So theta is equal to 0. Okay. Then another case, if theta is equal to 180. Theta is equal to 180 degree means this is shifted to here. That means this is a current carrying conductor. In this current carrying conductor, current is going like this, and this is the dl. dl, a point is here. Okay, so from this is the r vector. So here you see the r vector and dl is making an angle 180 degree. So if like this case, what about the magnetic field? That is, I am taking the dB is equal to mu 0 divided by 4 pi IDL sine 0 or 180. First I will take sine 0 divided by r square. What about sine 0 value? Sine 0 is 0 and sine 180 also 0. So dB is 0. dB is 0. That means if a point is along the axis of the current carrying conductor, the magnetic field is 0. Clear? Okay, this is the case 1. Next you will see case 2. Case 2. That is theta is equal to 90 degree. When theta is equal to 90 degree, current carrying conductor, this is r distance and p is like this. That is, it make an angle 90 degree. Okay, like this. So small current carrying conductor d. Okay. So what about dB? dB is equal to mu 0 divided by 4 pi IDL sine 90 divided by r square. Sine 90 value is to be 1. So dB is equal to mu 0 divided by 4 pi IDL divided by r square. Okay. This is about the case 2. Clear? Okay. This is about the case 2. Okay. This is about the Biot Savart law. Now we will see magnetic field produced by a straight current carrying conductor. Magnetic field produced by a straight current carrying conductor. So I am consider the straight current carrying conductor. This is the straight current carrying conductor. Okay, the current is to be in this direction. There is a point P, that is r distance from this current carrying conductor. This is a perpendicular distance. This point P is making an angle phi 1 with the one end of the conductor, and this is making an angle phi 2 with another end of the conductor. If you apply the Biot Savart law, and you can find out the formula, that is B is equal to mu 0 I by 4 pi r into sine phi 1 plus sine phi 2. Okay, clear? I is the current, r is the distance, there is a perpendicular distance from the current carrying conductor. Phi 1 is the angle made by the point to the one end, and phi 2 is the angle made by the point to the other end. Clear? Okay. Then we'll discuss about cases. In the case 1, if this is an infinitely long current carrying conductor, that means like this. Okay. If it is infinitely long, what is the magnetic field? Okay. So point P. If it is infinitely long, what about the phi 1 and phi 2? Initially this is the phi 1. This is increases, like this it will come. Again goes on, again goes on, like this, what you get now? 90 will get. The similar way here also you will get the 90 degree. That means phi 1 is equal to 90 degree and phi 2 is equal to 90 degree. If the wire is infinitely long, phi 1 and phi 2 are 90 degree. We will substitute that value. Then what you will get? B is equal to mu 0 I divided by 4 pi r sine 90 plus sine 90. What about sine 90? Sine 90 value is 1. 1 plus 1, 2. That 2 is divided with this. So you will get as B is equal to mu 0 I by 2 pi r. Okay, r is the perpendicular distance from it. Okay, this is the magnitude of magnetic field produced by a infinitely long straight current carrying conductor. How you will find out the direction of the magnetic field? You can find out by using right hand thumb rule. That means you have to imagine that you are holding this current carrying conductor in your right hand, and the curled fingers, the thumb you have to point in the direction of current, the curled fingers gives the magnetic field direction. That means here you will get the magnetic field direction is into it. This is the direction. Here also you can apply it. Okay, so the magnetic field B direction is like this, you will get. Okay, that is going into it. Clear? Okay, then next we will see another case. That is, this is a current carrying conductor. One end is infinitely long, but the point P is to be like this with the other end. So what about the angle? So here this angle is now here. After that it is increases, and again it will be increases. Again it is increases. So this angle become 90. What about this angle? This angle is 0. So phi 1 is 90 degree. What about phi 2? Phi 2 is 0. Now we can apply it. B is equal to mu 0 I by 4 pi r sin 90 plus sin 0. What about sin 0 value? Sin 0 value is 0. Sin 90 value 1. So B is equal to mu 0 I divided by 4 pi r. Okay. And what about the direction? If the current goes like this, magnetic field direction, you will get this like this. That is going into it. So this is the magnetic field direction. Okay, clear? If the current is coming out, going downwards, you will get the direction. That means here it is coming out. Okay, this is about the magnetic field produced by a straight current carrying conductor. Now we will see type 1. Find the magnetic field at the center of a current carrying square loop of side A. Okay. We need to find out magnetic field at the center of a current carrying square loop. So I am consider this is the square loop carries a current in this direction. Okay, I am name it as A, B, C, D. Center is P. I am consider this square loop is a 4 straight current carrying conductor. Okay, then all the straight current carrying conductor have same length. Okay, so this is the perpendicular distance r. One side they are given as A. Clear? Okay, then this angle is to be 45 degree. If it is to be perpendicular, this is 45 degree, and this is also 45 degree. So now I will find out the magnetic field produced by this AB at P. Okay, that is magnetic field due to this AB is equal to how much you get? That is mu 0 I by 4 pi r sin phi 1. What about phi 1 value? 45 plus sin phi 1 plus sin phi 2. That is also 45. Clear? Okay. Then the current is I. So mu 0 I by 4 pi r into sin 45 value 1 by root 2 plus 1 by root 2. So you will get it as mu 0 I by 4 pi r into 2 by 2 into 1 by root 2. This root 2 and 2 is cancelled. Root 2 is to be remaining. So root 2 mu 0 I by 4 pi r you will get. This is the magnetic field produced by AB section. What about BC? BC also make the same angle. This is also 45, this also same like CD and AD also. So all these another three section also produces same magnitude. What about the direction? You can see the direction here also. Intuit all the things, the direction is to be seen, so we can directly add it. Okay, so net magnetic field at P is, that is B net is equal to what you will get, 4 into this value, that is root 2 into mu 0 I divided by 4 pi r. 4 and 4 is cancelled, so you get as root 2 into mu 0 I by pi r net. Okay. What about r in terms of A? R is equal to A by 2. That I will substitute here. So B net is equal to what you will get? B net is equal to root 2 mu 0 I by pi into A by 2. This 2 will goes to top. So what you will get? So the net magnetic field at the point P is equal to 2 root 2 mu 0 I by pi A. Okay, mu 0 I by pi A. Okay, this is the magnetic field at the center of a current carrying square